Hello everyone, and welcome to Computer Science Dose. My name is Hazem, and I'm a software developer. In this video, I'm going to be introducing, with a hands-on example, Amazon's CDK. CDK stands for Cloud Development Kit. It is a set of tools that Amazon's created to make defining and deploying your application's infrastructure easier and more developer-friendly. These days, the line between your application and its infrastructure is virtually invisible. It is precisely tools like Amazon CDK the reason why we are seeing this evolution. We as developers nowadays are able to describe everything in terms of code. The idea behind CDK is pretty simple. You describe your infrastructure using your favorite language, and then you use CDK's command line tools to generate CloudFormation files that you later submit to AWS to provision the infrastructure for you. So we're going to deploy a containerized Springboot load-balanced Fargate application that will run on top of a cluster with an internet gateway, all contained within a VPC, or a virtual private cloud. If this sounds like fun, keep watching. All right, so to get started, let's go to github.com/csdose. So the code that we're looking for is in this repository, simple Springboot service AWS. Let's go in there. There's only one commit in there. And the code is pretty much, actually, let's go ahead and clone it. Clone. Perfect. So I'm going to run or open the application and run it later using IntelliJ, my favorite IDE. Now, you feel free to use whichever IDE that you like. This is where I've cloned my application. So right off the bat, you see that we have two folders that are the two main folders of this project. The first folder is a Spring Boot application. It is your, typical empty Spring Boot application, and it's got the annotation. It runs the application, and it's got one test, just context loads, pretty standard stuff, nothing interesting here. If you look at the POM file, we are using Java 1.8. We're depending on starter web, test, and actuator for two reasons. A, to have an out-of-the-box API that we can call to verify that we've deployed the application correctly, and to have an endpoint for health checks. So let's actually try and run this application. I'll use Postman to, I've already written down the endpoint URL. So if you go back to IntelliJ, yeah, so it started on port 8080. Let's try it out. There you go. Works. If you remove health at the end, you get more information. Yeah, that's it. It works locally. That's very good. Yeah, so once you execute Maven package or install, you're going to end up with an artifact that is named Springboot application AWS. So let's try that. We have a target folder created by IntelliJ. I'm just going to delete it, and which is the equivalent of running clean. I'm just going to run package there, and yeah, I need to cdn the actual Springboot application and Maven package. Well, success. Now we should have a target folder, and we should have the Springboot-application-AWS jar. Now, later, we're going to use in the Docker file this jar. We're going to start with a Linux Alpine JDK version 8 image, and we're going to copy that jar into app.jar, and we're going to specify that the entry point is going to be Java. Actually, let me show you that. So if you change into target, you can run java-jar. Yeah, I have it typed already. And it should start your application and run it. So there you have it. You have two endpoints exposed. If you go in Postman and you send the request, you get the response. If you go back in IntelliJ and kill the process, it's gone. So that's pretty much it for the first folder. We All we have to do now is to build a Docker image. And that's actually an interesting point, because this example is dealing with a Springboot application, but it can be any containerized application that you want. I actually went with Springboot because it is one of my favorite frameworks. I use it every day, and it is one of the most commonly used frameworks. But feel free to use any framework, any Dockerized image that you want. It will all be compatible with this second project, or the second folder, which has the AWS infrastructure code and the CDK code that is going to deploy this containerized application to AWS. Now let's get to the second part of the project. We're looking at Springboot application AWS infra. This is a Node.js application, and it contains the, let me close these out. It contains the AWS infrastructure code that we're going to be using to deploy our application. So the first thing that I like to do whenever I'm handed or whenever I'm inspecting a Node.js application is to look at the package.json, which is in principle the same as the POM file. It's got your, so the POM file's got your basic information for the application, the name, the version, the dependencies, and the build process. And the same thing goes here. So you've got the name, the version, the bin. The bin basically is the, I don't want to say binaries, they're executed because they're in source code format, but they're the executables that the application provides. And as we'll come to see later, this is this is the entry point to our application, the Springboot Fargate CDK .js, which is actually a TS file, but it gets translated when you build your application. Which brings us to scripts. Scripts is just a place where you can define scripts, or you can define commands and give them a name, a readable name. The interesting script that we're going to look at is the clean deploy. I've written this so that I don't have to write this in the terminal every time I need to deploy the application, which we're going to see later in the video. You've got your dev dependencies here, and you've got your dependencies. We're depending on ECS, EC2, ECS, ECS patterns, and the CDK core, and the source map support. So that's pretty much it. So if you close out of that, now if you haven't done an npm install, so where am I? Springboot application. Let's go back. Infra. So if you haven't done npm install, you should do that so that you could get all your dependencies installed in node_modules folder, so that you're able to run the application. But before we run it, I thought I'll walk you through what happens. So this, like I said, this file or this script is the entry point to our application. And if you just look what we have here, we have we create a new instance of a CDK app that we're importing from the core module of CDK. And then we're creating a stack within the app. So it is your CloudFormation. It is going to be translated, or it will generate a CloudFormation stack that is going to be deployed to AWS, as we will see later in the video. And we're passing to it an instance of the app, and we're naming it example app. Now, if you go in there, that's the file containing that class. So what essentially happens is you've got your class, and it extends the CDK stack, which you can also find in the AWS CDK core. And you're going to have to, well, you don't have to, but what you typically do is you define your infrastructure within the constructor of that stack. So you're calling the super method or the super constructor, and you begin defining the resources that you're going to need or rely on to run your application. So what I've done here is pretty simple. I have a VPC, and that VPC has the ID example, Springboot application VPC. VPC is a virtual private cloud, by the way. And I'm passing to it a, what would you call it? The properties object, the VPC properties. Passing, you can inspect that properties. It's an interface, and if you, let me close this out. If you look at the structure of, should come up, yeah. So if you look at the structure, you can pass more than, so I just passed those two parameters. So the max AZs, the max number of availability zones to use, and the NAT, the number of NAT gateways instances to create. NAT is, if you're not familiar, network address translation protocol. It's just a way for your resources to access the internet and to be accessed from the internet. I'm not going to go into too much details. You can look up these things yourself, but for the purpose of this tutorial, I'm just defining those two properties within the VPC properties object. So once you have a VPC object, you can move on to creating an application cluster. Now that cluster is an ECS cluster, and it's got like you've done here, you give it an ID and then you give it a properties object. So if you go in here and you look at the object like we did before, cluster props, yeah. So you've got, we're passing to it, let me just have a look here again. So I'm passing to it an instance of the VPC. I think that's optional. If you look, we're done with this. So yeah, it's an optional parameter. So if your cluster is running within a VPC, you pass that instance to it and the cluster name. So we're naming it, you can name it whatever you want. I've named the application cluster. And then once that's created, we've got a reference to that object that we can use in our application load balance Fargate service. So we're accessing an ECS pattern called the application load balance Fargate service, and we're creating that object. We're giving it this ID, and just like we did earlier, we're giving it a properties object, and you can look up the properties object and see what you can pass to it. For our use case, we've passed, so these kind of applications, they typically run on top of a cluster, so you're going to need to have a cluster object. So we've created that already, that, if you recall, runs within a VPC that has a one NAT gateway that this application will be able to utilize to, like I said, communicate with the outside world. The desired count is 2. So the way these applications run is they're run horizontally. So it is a containerized application, and you're spinning container instances. And the desired count that we look for, ideally, let's say in the normal case, is 2 instances of the image that we are going to be creating from the Springboot application that we have here. So that's our desired count. Now for the CPU and memory limit, this is a bit of an interesting story. So I think we need to have a look at the documentation here to understand it more. So you've got what they call CPU units. It is the unit that you use to specify how much computational power you would like each instance to have. So I think what we went for was 256, yeah, for the CPU value, which means that you get a quarter virtual CPU. So if you think of it as you've got virtual CPUs at your disposal, every instance that you run will consume 1/4 of a virtual CPU. So if you're running 4 instances, that means that the 4 instances will consume 1 virtual CPU. Also, of course, the amount of memory available for each instance is 0.5 gigabyte up to 2 gigabytes. So if your application is memory intensive and you need more than 2 gigs of memory, then you want to, even if you're not doing anything heavy CPU wise, if you just have a lot of stuff in memory that you need to have at the same time, and it should be more than 2 gigabytes, then you will have to increase your CPU units as well. You could pick the value that is suitable for, and remember, this is not for the entire cluster. This is per instance. That's the CPU value. If you look at the memory limit, so this unit means that, you know how mega can be used as 1,000 or 1,024? Well, when you say MI, it just means it's definitely 1,024. It's not 1,000. So that's what this notation here means. You can look it up. So this is the amount of memory that is used, and you want to be sure that when you're using a value, you want to be sure that the value is compatible with the CPU value that you've picked before. So you can read about those more. I'm not going to go into any more details in here. Let's get to the task image options. Now your containers are going to be instantiated off an image. Which image are we talking about here? So since we have a Docker file here, we can use that to create an image. And so one way to do that, let me get rid of that. One way to do that is to pass, I forget what's the name of this object. It's called application load balance task image options. So if you go over there, you inspect the properties of that image. So I'm using two parameters here, or two fields. So the image field, obviously, because you're defining the task image, so you need to have an image. And I'm using this function from asset. So this function, you're passing to it a string for the directory of a project that has a Docker file. So like I said, it doesn't have to be a Springboot application. It could be any application with a Docker file that will generate an image. So it doesn't have to, it could be any application. And then you're given it, if you're not familiar with this notation, when you run, so later when we build and deploy the infrastructure, we're going to be in the infra directory. So you go CDK and then you run the stuff. So this is your working directory. So if you want to reference relative from your position here, if you want to reference the Springboot app, then you go CD, which change directory. You do that. So that's the path, the relative path from the infrastructure directory to the Springboot application directory, where you have the Docker file here. So that's what we've done here. I hope that's clear. And for the container port, it's 8080. Now, if you remember, we used Postman over the port 8080, which is the default port when you're using Springboot. And that should be it for the application, for the application load balance Fargate service. Now, once that is created, you're gonna want to reference that application again, and it will have set some defaults for you and generated some objects within that for you. And one of them is the target group. So you want to configure the health check for the target group, and you pass to it, I suppose, health check object. And then if you go in that object, it's an interface, and you see what's in there. So we've got, I think, I'm not sure what I defined here. So yeah, you've got port. So port is pretty self-explanatory. And here we're using the traffic port, which is the 8080. You could have your health check running on a different port. That's like, it's up to you. And the path is the endpoint that you're going to be testing for the health check. And the path to that endpoint, like we saw earlier, because we're using the actuator dependency, so the path is actuator/health. Go back to IntelliJ. I'm going to skip those for now. I'm going to look at this. So that's the healthy HTTP codes. So if you get 200, I guess I could just skip those. But in any case, if you get any of those status codes, HTTP status codes, then your health check will assume that the instance that it's checking is fine. Now, Okay, let's talk about those now. So the interval, if you look at the documentation, is the approximate number of seconds between health checks for an individual target. So it's just the frequency that every 5 seconds you're performing a health check, you're sending a health check request. And for the timeout, it is the amount of time in seconds during which no response for a target means so there's two ways to get a failure. So you either getting a status that is, I don't want to say two ways, maybe two ways that I know of. Either you get one of those, a status that is different to those, or your request times out, which means that the instance is basically unable to take on more requests, which means it's not really that healthy. Let's see, healthy threshold count. So what does that mean? The number of consecutive health checks successes required before considering an unhealthy target healthy. So there are two states. Your target is either healthy or unhealthy. So if your target is currently unhealthy and you perform 2 health checks, so that will take, like we said, 10 seconds. So over 10 seconds, you performed 2 health checks and you got status 200 from both, then that is the threshold that you've passed to switch from the unhealthy state to the healthy state. So your instance is considered, or target is considered healthy by then. The unhealthy threshold count is exactly the opposite. The number of consecutive health checks failures required. So if you're in the healthy state, you need to fail twice consecutively to be considered for your instance or your target to be considered unhealthy. And we talked about this. So that's it for, like I said, this object was created here. It is our application object that is running, like we said, on top of a cluster that is running within a VPC. So it all ties together. All right, so for the last 2 bits here, we've got the auto-scaling task count. So I don't know if you recall, yeah, so we said here that the desired count is 2 instances. That is what we normally aim for, the normal state. And here the minimum capacity is obviously, it doesn't make sense to go below 2 if your desired count is 2. So the minimum capacity is 2 and the maximum capacity, well, you can set it to whatever you want. This is a tutorial test application. It doesn't matter really. So I just set it to 4, but then you can have a conversation about how much load you're expecting and how much growth you're expecting and how much money you're willing to spend, etc., etc. The last bit is the CPU utilization scaling. So you give it an ID and then you give it a properties object, just like we did earlier with everything else. And the target. So let's just go here and have a look at what it says. So it scales in or out to achieve a target CPU utilization. So the target utilization that we want is 45%. All right. So it will scale in or out to maintain that target. And this is just the name of the policy that we're setting here, 40%, 45%. You can set that value to whatever makes sense to you. I just picked an arbitrary value. I didn't give it much thought, honestly. The scale in, cool down period after a scale in activity completes before another scale in activity can start. And I think here it is period after scale out activity completes before another scale out activity starts. So to give you a sense of what this actually means, let's say that your application starts with the desired count, which is the 2 instances here, and then you receive a lot of traffic. So your scaling policy will sense that and will start scaling out instances for you. So you're going to add one more instance, and then the load is increasing and increasing. Then you're going to add more instances. And what this means is once you've added an instance, wait for 30 seconds before you consider adding another instance. And the same thing goes, well, once the load is cooling off, before you remove the next instance, wait for 30 seconds. So this value, you can set it to a number that suits your application and will allow for a smooth transition between different number of running instances at the same time. All right, so I think we've covered everything in this file so far and in this file, so we're good to go. Now, the first thing we want to do is to cd into the infra project. And this file is interesting, so I'm going to delete it first. And I'm going to try and CDK synth and see what happens if we don't have that file. And you get that error that says you need to have the app parameter, or you need to have a definition of that app in your cdk.json. So that's why we had the file. And the file essentially says, instructs the CDK that the entry point to synthing the application, aka transforming the application to a CloudFormation template, is executing this script here. All right, to create a new app and to create a new stack within that app. And the way you do it, so how do you tell a command line tool to execute a TS file? Well, you start with node package execute, and then the package you're executing is TS node, which is transpile and interpret. So it transpiles so it takes one parameter and it transpiles it to JavaScript, and then it executes it over on top of node. And it relies on, like we said, the TS config file. So that's essentially what happens. And let me try and rerun synth again. Now, before I do that, actually, notice that we have only 3 folders here under infra. And let's run it and see what happens. Yeah, so you see things are happening, resources are being generated. And if you scroll all the way down, if you refresh, you get cdk.out folder. And in there, you've got your example app stack that you can use now to deploy your application to AWS. So the next step is CDK deploy. That will basically, it will generate a list of changes. So I'm going to say yes. Now it's failing because it needs a certain stack to be. So if I go to Firefox and log in into, oh, by the way, I was meaning to talk about this. So if you don't have the CDK command, you may be able to get it using npm install AWS CDK. And if you don't have npm on a Mac, you can get npm using brew. So let's go into the console. All right, so I am in EU Central 1, I think. That's Frankfurt. Yeah, EU Central 1. So it was failing because I don't have the toolkit stack. So let's create that toolkit stack first. And the way to do it is to copy this and paste it. And you want to replace the unknown region with EU Central, and this is my account. Right. So you execute that first, and you only have to execute it for the first time, and it will, yeah, as you see, it will start creating your CDK toolkit stack. I'll pause the video, and once that's done, I'll get back. All right, so this has been deployed successfully. And if you refresh, you see that the stack has a create complete status. Now we can go back and try and deploy our application again. So CDK deploy. Now that we have the stack, it shouldn't complain. And there you go. It's building the image. Now you want to make sure that you have Docker running. So if you go to AWS, you see that you've got a stack being created. You can see the events. You can see the resources. So I'll just pause the video, and once it's created, I'll continue. And there you go. Our stack is being created successfully, and it's got some outputs that we're going to look at in a second. But let's just go to the console, refresh. So that's our example app. It's been created, and the outputs are also available in here. So if you click on this guy, you get a white label error page. What this essentially means is that it's Spring's way of saying that there is no endpoint to serve where we're requesting, which is the root. But if we go and hit actuator, you see that our application is actually running. Now let's go into the resources and see. The thing that we'd be looking for is the cluster. So the application cluster is, if you remember, this was the cluster that we created. We gave it the name application cluster. So if you go back to Firefox, that's exactly the name that you see. And on top of that cluster, you have services running. So we've only defined one service, which is the application load balanced Fargate service. We've defined one application, and we can clearly see it running on top of that cluster. Now, if you go and inspect that, you see that it has tasks running, or simply instances of our application, and they are running on port 8080. You can see the auto scaling. The minimum task is 2, as we've defined here. The minimum capacity is 2, and the maximum capacity is 4, as you can see in the bottom right. So if you look at the desired count, it's 2. The running count is 2 because there's no need to scale out. I'm sure if we stress the application, it will start scaling out. The auto scaling policy that we've defined is CPU auto scaling policy. If you recall, it is this one. And the target CPU utilization percent is 45, which is what we have here. And here you can see the logs of the application. So that's basically all of the tasks that are running here. Their logs are combined in this tab, but if you're interested in the logs of each task, you can view it individually from the task itself. And you can see logs here. One other thing that I want to show you is this should have created a Cloud Watch group. So let's go and verify that. Logs, log groups. So yeah, I've got that log group there, and you have 2 log streams. So if we look at the tasks that we have, so this is ending BAD, which is the log stream for this task, and the log stream for this task is 51D, which is this one. And like I said, you can access the logs individually from this tab, but if your task is killed or thrown away for some reason, then you have the logs in here as well. Now let's go ahead and make some changes to our application just to see how CDK helps us to modify our existing applications and their infrastructures with minimal effort. So I'm going to create a controller here. So class controller. By the way, don't judge me. This is horrible. I know. Don't do this at home. Yeah, so string get hello and get mapping. You wanna say this is root, and you wanna return hello from Springboot. All right. If we run this locally, see what happens. It should serve Spare Postman. Yeah, so it should return that. Let's change the infrastructure as well, just a little bit. So I'm going to change this to 70%. I'm going to change this to 3, and the desired count is 3. So we're going to add one more instance. Maybe we can also change the container port to 8081. And so we're going to have to go in our application, Java. So we have to create a directory. Yep, resources. And we have to create a file called application.properties, and we create it. Oops. And the property we are interested in is server.ports. And we're going to define the port to be 8081. That's it. So if you run this again, just to be sure, go to Postman. It shouldn't work. If you change it to 8081, it should work now. So go back to IntelliJ. So first, we're going to have to build our artifact again. I'm going to execute maven clean package. All right, that's done. And now we can use the script in package.json called clean deploy. So what this will do is it will remove the cdk.out, it will synth, and then it will deploy to AWS. So let's try it. npm run clean deploy. And now it's rebuilding a new Docker image. Once it's finished, it's going to start deploying. So we're going to go to Firefox and just hit refresh until we see some action. So now, as we refresh, we see that the status changes from create complete to update in progress. And you can see the events. So the example application is being updated at the moment. So we'll let it do its thing. I'll pause the video now and I will get back to you once the update is finished. All right, so the stack is finished updating. As you can see, update complete. If you look at the command line, it's indicating that the update is complete as well. And yeah, let's verify that our changes have been made. So the first thing is the controller that we've added. So let's actually try and hit the endpoint, see if it works. So as you can see, we're getting the value that we set in the root controller. So we're not getting that white label error anymore. And if this is working, so it means that our change that we made for the containers to work on port 8081 is working. And the changes that we've made in the stack regarding port 8081 are working as well. Let's see now if the desired count and the minimum capacity are also changed. So if you go back to Firefox, you want to look at the cluster. So the application cluster. So you see that we have 3 running Fargate tasks. If we go into the application itself, we see that the container port has been updated. And if you look at the tasks, we have 3 tasks running. And if we head over to auto scaling, we see that the minimum number of tasks have been updated to 3, while 4 remain the same, and the CPU utilization is now 70%. And this brings us to the end of this video. It's been a long one, and I hope you didn't find it tedious. I hope you found it useful, and you've enjoyed it as much as I've enjoyed making it. If you have any comments or suggestions or corrections, or if at any point you thought I should have done things better, please do let me know in the comments below. I'd love to learn and to gather as much feedback as I can. And I look forward to seeing you in future videos. I'll definitely be making more AWS focused content in the future. So if that's something that interests you, please consider subscribing. I'm Hazem. Thank you for watching, and I'll catch you in the next one.